I hope I'll survive the lecture.
We need to improve. So we need to improve.
Good afternoon. Today I have changed the plan today for the topic to be discussed. I'll be talking about automation in construction today with a particular focus on robotics. The reason why I'm doing this is because this is the best idea I could come to help you identify what are the information flows needed to achieve something. So when you are relying on providing to anybody basic instructions for their purposes, to coordinate some task on any construction project, you can sometimes rely on their understanding of the issues. You can ask an engineer to solve some structural calculations for any problems, and you can assume that under many circumstances, these people will fill in the gaps of the information missing. Humans can be very active in the way in which they deal with the information. They tend to fill with the knowledge and research and feedback loops all the gaps of information exchanges that you have left open, that you have left undealt. That's not very simple when you're dealing with robots. So today I'm trying to bring to you a set of research projects and research activities that are sometimes based in construction, but sometimes take a broader industry range, so that you can start thinking about the problems associated with information exchange in these areas, to really focus on what is needed to achieve the goals that these people set for themselves. Of course, sorry. The second goal that I have is to make sure that you understand that this is going to happen anyway at some point. So the reason that this is going to happen is because it has happened everywhere else. So this is a chart comparing productivity rates for two different industries. Construction is the blue line, and automotive is purple pink. At some point in the mid-90s, the industry of automotive production just changed gear. They embraced robotics for good. They reduced, they analyzed very carefully whatever could be done with in streamlining and improving the productivity of their manufacturing lines. You have probably done something about that with Eric, I suppose. Eric would say that 99% of this is associated with lean construction, with lean methods. My view is that there is at least another big contributor to that, which is actually huge efforts in automating processes that could be automated.
Probably better done with. It would probably be better improved with modular design, or
Say again, sorry?
It would probably be better improved if they started with more modular design, you know.
Yeah, as well. I mean, all sorts, and this can be done fairly easily in the. Will I survive this lecture, or will I die here in front of you? Sorry. So, the automotive industry could invest substantial amount of money in improving the processes of delivering cars, because there were there were just a few competitors that were competing against each other. The construction industry is much more fragmented, so we haven't been able to identify and improve on the integration and modularization of design and such to the same extent, because the interests are much more dispersed in our industry. But let's see at what we have done. We have used computers to aid construction in a number of areas. We use computer massively to improve in our design processes. We have all mentioned building information modeling. We are at the early stages of the revolution of BIM, but it's impacting seriously. Planning, yes, we do some planning with automation and computer support. We have all sorts of planning activities, and small levels of automation are crippling in. Suppliers relationship is now the information flows for supplier relationships are automated in some sort. They are digitalized, of course. They are not automated as in we are still to improve the ways in which we come to decision making in that area, but it's coming up. In the production stages instead, there is very little uptake of these potential technologies. We have seen a little of prefabrication that points to, as you were referring to, modular design and modular behaviors to improve productivity. The erection of buildings is mostly done by humans. You have humans controlling all aspects of it. People assemble stuff, people dismount stuff. We have machines to help giving, helping with dealing with the huge forces that we deal with. So we have cranes, we have these kind of things, but they're not automated, they're controlled by humans. So the target that we are aiming at is full on-site automation. And the difficulty that we're facing is that our industry is very diverse and is very fragmented, and every construction site is different from the other. So where it is easy for the automotive industry to put a robot that does the same thing again and again, and you know that the result will be some level of quality of the machines, in a construction site you cannot rely on that, because there will be all sorts of types of information and environment differences between all different projects that need to be taken into account to achieve any level of automation. And of course we're dealing with heavy objects, we're dealing with large tolerances, so products at the moment are, products of construction rely on very large tolerances. You can have errors of a couple of inches on some installations of some elements. So with that huge tolerance problem, automating the steps of a robot that achieves, mounts something on something else becomes impossible. Yes?
Recently they've developed the latest 3D printer for housing.
Yeah.
It's just coming onto the market. Well, testing on the market at the moment.
No, but thanks for asking. No, that's not true. We don't have a 3D printer at the moment for...
It was only a couple of weeks ago they developed one.
We'll discuss this. I mean, it's in this slide set.
Yeah.
We'll come to that, but no, it's not available on the market yet. So, and first of all, we have to start to deal with the low level of standardization that we are facing. And there are two ways you can deal with this. Either by increasing the level of industrialization and prefabrication that we use in our design and in the definition of our models, or increasing to the ability that we have in terms of automation to respond creatively to problems. So adapt the behaviors of robots and machines to this configuration that they find locally once they come to site. So this is one, you have only two ways. Nevertheless, something has been done already. So there are bullet points here that are invisible on this projector, but thanks to GPS and laser data acquisition on site, pavers and rollers like this can be completely automated. So this was actually a completely automated roller with a GPS antenna on it. You put it at the end of the track and it starts moving up and down until when? Until other sensors tell it that the quality of the pavement has reached desired targets. This seems trivial, but it's a big step. You don't have an operator that evaluates with more or less care the amount of work that it has done. That he has done. You have a machine that works and goes on performing a task until it reaches some level of quality. So you can incorporate a quality target in the behavior of these machines. So there will be laser sensors that check speed, temperature, layer thickness, and traveling distance, and smoothness of the surface through laser scanning to detect whether they need to have another passage at a specific area or not. This also proved to be a good field of research because these machines can be helpful, but they work in collaboration with others. And by studying carefully what is the best sequence of operation and what is the best behavior that they can play together, you can improve efficiency in the delivery of road construction. But that takes cooperation between machines. So that takes a big picture of what are the best activities to be performed, in what order, in what kind of timing sequences, and then sequencing. And then you have to have communication channels and information channels that exchange this data between these machines so that they can agree on behaviors to be performed. Another situation where this was possible was the automation of single large machines. So digging, for instance. Many of the operations that happen inside these large machines are completely automated. And they are automated because once you have things like this, or this, bring the factory to the site. So they are so huge that they can transform any site into a streamlined process. So you have the digger here, and you have all sorts of automation inside the body of the machine to transfer the materials that you are dealing with, and analyze them and sort them, and divide channels, and you're bringing a factory basically to the problem rather than dealing with it a step at a time. So this was done in the past with large tasks, but we're now observing a trend that is bringing these automation behaviors to small tasks. Automated excavators we are observing now to be trialed. I didn't see anything on site already, but excavators are fairly dangerous objects to have around moving independently. So they are carefully developing their ability to decide what is the best set of action to move the land or to dig a trench or things like that. But it's fairly easily done in terms of data. You put a 3D laser scanner and to model the surface, you identify what are the portions of land that need to be moved. Nice to have a crowd like that.
It's like a stadium.
And then in real time, new laser scans acquisitions will model the 3D landscape to tell the system what is the feedback, what did he achieve with any of the movements, and what needs to be done next as a consequence. So automated excavators we've seen. Automated lifts and cranes, we've seen them even more. These are actually crippling in real construction sites. Automation of processes of transferring items from one place to another have been successfully achieved and used on real construction sites. Automated inspection robots also. Large civil infrastructures, a bridge, a marine, an offshore plant, things like that, are now full of small machines like this that move and walk across the structure with sensors on with sensors on that scan all the relevant portions, scans for bolts, scan and rust, and things like that to check whether everything is as expected. maintenance and inspection of the status of the expensive equipment is a very expensive, used to be a very expensive task, but this level of automation is helping to bring those costs down. You have a question?
Yeah, so didn't Australia have the automated painting robot that they were testing on one of the bridges?
There are plenty, yes.
Yeah.
There are plenty of tools. But you know, if you have a fairly controlled environment, so you know what is the task, you have a pretty good picture of the problem at hand, you have an extremely detailed model of the bridge. Well, it's fairly, it's not terribly complicated to think of a small robot that performs a single task extremely efficiently. And possibly you could actually integrate that with things like this, that don't just paint over the whole bridge because, we need to do that anyway, but just could go around and check for problems and fix those problems. So once you have, this level of ability to routinely do things cheaply, well, you can change that, the plan of your maintenance. Larger robots are also in use. We have robots now to install windows with a single operator. It comes down, press the button, the robot will react in real time to forces of the wind and things like that, and progress to the next step of installation when the conditions are met. The big, we've always had cranes. That's not the issue. The issue is that these machines have started to have intelligence on board, start to make decisions of what is the best course of action to have that window installed in different environmental situations. So we have, again, concrete compactors and finishers that produce, that go on, you unleash on a floor, and they will go on and do what it's needed until the floor is perfectly level. Or, again, coming back to this previous idea, until the floor is leveled to the agreed standard of quality. Sensors, feedback. We have robots that lay bricks for us. The point is still that most of these tasks rely on staff being around. These are not fully automated things. They could be fully automated, but they still need supervision for health and safety reasons and a number of other considerations. And they are generally very verticalized, very specialized to deal with quite narrow areas of problems, right? That can be sorted by them. Can we improve humans on site? Probably we can. We can add situations like kit like that to automatically detect when everybody is on a construction site. These well, you can't read it here, but these helmets will have a GPS positioning system on, and they will have an antenna that will allow them to communicate constantly with the hub, and therefore the position of every construction worker on site is negotiated. And this information could be used to decide whether to carry on or stop some maybe dangerous activities in that area, and improve health and safety. So this is active security is one of the first areas of enhancement of information flows on a construction site. But we can think of having semi-clever equipment to support yep, there you go. Could you please take this one to the fourth? It's difficult to see on this projector. I always overestimate. But you can put on a number of kilograms on the back of this guy, and he say, "Oh yeah, well, it can still walk," and then it can run, and run sideways, and crawl, and do all sorts of stuff. Of course, these things are thought for again, everything will start on in war environments. So everything will be, all new technologies will always be developed to go to war. But eventually, this will come to construction. Exoskeletons that will improve the ability of people to run, walk, and move around. And there you go. You can walk and run with them, and go down the stairs without. So it's carrying things like that. Yeah, I mean these are robots. That's not. This is actually a robot.
Is that making it easier to run, or
yeah? I mean,
support?
On a sideline, it's not connected to it, but things like this have been used to make people that are
Disabled.
paralyzed walk again.
Yeah.
So you can integrate, the different environments and different targets. But my point is that there are sensors all over. This is not just a piece of steel, right? It has active energy. It uses active energy and real-time sensors to compensate for movements that are unexpected or forces that need to be reacted to. So it's clever, this machine. It's responding in real time, sensing. So it looks like just an exoskeleton, but it's actually a robot. More information specifically on the whole area, if you are interested, is available on this book that is, it's a free download. Just have a look at it. It's just to have ideas for your information exchanges. If you think that you have any areas of interest that, and you tackle that area of interest by thinking, what if I put a robot to solve that problem? That is a way to really think about all the information exchanges that are needed. Because you'll never expect that the robot will fill in the gaps, right? You understand all the information that needs to be provided for them to solve the problem. So have a look at that. Other areas in which innovation is coming to us is the area of generative design. So in the past, you've probably considered that designers will solve all sorts of issues, right? I'm an architect, I will take care of each room individually, and then we'll define it carefully how a technical solution will support a design objective that I have, and carefully look at all the ways in which this technical solution interacts with each other, with all the other elements of my construction stage. But of course, if you are to design a canopy like that, that can take a lot of time, right? And of course, well, no, not a problem. We have plenty of money available in the construction industry, right? No. Only exceptional projects have plenty of money. Most projects are tight on budgets. So, why would you have somebody detail the measure and the size of all these different items carefully and how they interact with each other? You won't. The only solution, if you really want to build something like that, is to have an automated algorithm decide on basic functions. So I want larger items here, smaller items there, a gradient of dimensions, and then have a little algorithm to decide what is the best shape of the specific element. And on top of that, you have to be able then to produce these different elements. So the next step is actually to transfer this information to the computer-aided manufacturing industry, so that files will be exported from these kind of models directly to the equipment that cuts the different pieces of materials to the exact shape, and compute all number of elements that are needed. So computers have also unique abilities.
Different results. Architects.
If you want, to build something, you know, beautiful, you can call Michelangelo and ask him to paint your ceilings, right? But in some other situation, you don't have that amount of money. But maybe you can still do complex stuff by automating them in such a way that they will become cheap. So if you have access to, for a couple of weeks, to an item like that, you can think of a whole facade of a large building where every brick is laid out according to a generative pattern in a very precisely determined position, so that these walls or these prefabricated solutions are customly designed, stacked, and each individually designed and built, stacked and shipped to site for final installation. So I didn't highlight this during the video. Watch the videos when in your own time in the weeks to come, but I wanted to show you how what it's doing now is to, yeah, there you go. It's putting some glue or some sort of concrete on these bricks, but not on all the surface. It's putting that only on those areas where this brick will be touching other bricks. Everything else, no, perfectly clean. So you're, you know, every single gesture that these things do is very carefully controlled. It's not just one of those large-scale automation processes that you see in industry. So there are unique abilities that these machines have. Let's try and think of ways to exploit them. Anything else? Yeah, well, some of them fly. This is a bit unrealistic. Have you seen? How many of you have seen this in the past in the general media?
What it is?
It's these are quadcopters.
Amazon.
No, before that, a couple of years before. Quadcopters would pick up a brick and go on a specific side and drop it down. But carefully think whether it is in the right place. Yep, little correction, bam, laid down. And then another quadcopter starts and picks up a new brick and then lifts it off. There you go.
Must be polystyrene or something like that.
These are very light bricks, of course. Yeah. Pretty good. Give it enough time, they build the whole structure. You give a generative design, and they build the whole structure. Now, this was absolute marketing stunt, right? I want to make this clear. There is no real innovation here, other than the demonstrated ability that we have to control swarms of elements. So multiple robots interacting together for a scope. That's the bit I wanted to highlight. And you know, this was, you know, but of course there is no current need to have robots that are flying to carry these things. But robots on wheels would be probably just as good. They make, you know, less marketing effect. So, are there other unique abilities that we can exploit from robots? And there are. How many of you are familiar with this game? You put something on your finger and then you go balancing it, right? You stick, you go beautiful, and you keep it upright. That's brilliant. And there are machines that can do that. This is a machine that keeps music is really something here. So how do I show? Yeah. So you have this pendulum. You can move something on one axis, right? And you want to keep it upright. So that's the machine. It can move in 2 directions, and there you go. Brilliant. Now it looks like it's still, but it's not. It's micro moving, of course, the thing to compensate for all those small forces, wind, whatever, somebody opening a door, a vibration on the floor, that would make that fall, right? It's not just still, it's micromanaging the problem of keeping this pendulum still. Yeah, I mean, we can do that, that's easy. But, so as soon as you take power off, it falls, okay? Just to demonstrate that it was actually actively responding to the challenge. Now think of a solution where the stick that you want to balance actually have a hinge in the center, right? So it's 2 sticks that have a hinge in the middle, and you still want to balance that. That's a more complicated task, right? So can a computer deal with that? Well, it can if it is programmed in such a way that will give to the system the right amount of energy to start with, and then start to regulate this apparently crazy movement so that
Good.
what? It's still, of course, it's still running the same software. It's going, no, I want to keep this upright. Sorry, no, it doesn't matter if you push. I can react so fast that the thing will not fall. It's gonna happen. These things will have features that we can only dream about. So it's worth starting to think of the construction industry for how complex the environment we are playing it is, as a place where unique abilities, speed, strength, intelligence can provide a substantial change. This will need a serious rethinking of all the information processes of the desire and information exchanges. Of course, in the short term, you can start thinking about, okay, I need to move that table to that door. I need to install that door. I need to paint the ceiling. Whatever it is they need to do. At the beginning, this information, the information flow needed will be very simple: geometries, location, tasks, forces, materials. Where are they? How do I pick them up? What is the equipment that I need? These are the very basic questions that we need to deal with in these early stages. But eventually, in the long term, I can envision a situation when I go to an artificial intelligence and tell it, yeah, I bought this land in Tuscany. I need to go there with my family. How many of you are there? 24. It's a large family. And they will go, fine. And build the house. My point is that sometimes it happens like that with an architect. Now you just negotiate the price. I need a house like that. You design it. I don't mind. I'm coming to you as an architect because I trust your ability to build a beautiful building for me. Eventually, we could think the same could happen with an artificial intelligence. You set it a task, you give it a budget, and off you go. You build my house for me. Thank you very much. What information exchanges are needed at that level just a benefit realization plan. I need that house by that time, and this is your budget. Or maybe we want to have intermediate levels of control. The point I'm trying to make here is that in any of the problems that you will be facing when it comes to information flows, there is no unique solution. You need to control these flows to make sure that they comply with the risk and value strategy that you have for your projects. Who is in control of what decision and when and why is an important factor to be able to define information flows for your projects. This is very recent news, and I just added it here because I thought it was. This is Harvard. I'll just launch the video in the background and mute it. But the idea is that they think, can I set up a computing system that will arrange the behaviors of all these tiny robots, building up, erecting something, without giving them individually tailored instructions? So they started looking at termites and how termites behave to build very complex structures. And they try to mimic this behavior, so each robot is given a very short and small amount of information that are mostly interaction rules. How do these people need to interact with people? How do these robots need to interact with each other? And once you give them these rules, they end up building, and this is a simulation of that kind of thing, the structure that you designed. So you start from a design, and you transform that, not in individual tasks, but in generic rules that, if applied consistently by a large number of robots, realize a complex infrastructure. Wow. So the type of information that flows in these things is substantially different. And I want to go back to my lecture. So, one of the tasks of our engineering, the basic solution that most people think of is, okay, but we know that the industry will never change, so one of the solutions would be we'll just replace humans with robots that are shaped like humans and have the same abilities like humans have, and let them do the hard work. That's it. And we are on the right track. This is, I mean, you have all seen robots running, right? At least recently. How many of you have seen that robots run? Can you please, just to make it right? So you can push them and they won't fall, and people think, yeah, fine, you push it, it won't fall. No big deal, right? Except, well, I mean, we achieved this 3, 4, 5 years ago, and now they work. They just work because they have not. Previously, the approach that we were having to these problems was, I need to define a software that decides exactly what to do during each step of the walk so that I won't fall. The current approach is, I will give this robot the intelligence to react to things that happen with the target. And they started noticing that then when they did this, robot did like man. Started taking risks and went to take positions that are not stable. Walking for humans is not walking, is controlling fall. I'm falling, I'm falling, I'm falling, I'm falling. Machines learn how to fall to run and walk efficiently. So abstracting the needs allowed robots to behave differently. And of course, again, DARPA funded massively, big companies such as Boston Dynamics that won a number of DARPA competitions, and Big Dog is one of the results of this research. This is 4 or 5 years old videos. I'm not sure how many of you have seen this. You know, antenna, weight, go. That's your target. Bring this weight there. It's very noisy. Like a huge fly, but so people think, oh, it never happened. Construction will never have robots because, you know, it's a complicated environment. Yes, it is. But if we humans can deal with that, robots soon will be able to. Eyes, yeah, dealt with that. Thank you very much. Terminator, anybody?
You could send that to Sochi probably to the Olympics.
Freaking hell. So, guess who bought these people? No. Worse.
What?
No. So DARPA, the American branch of the research branch of the U.S. Army, funded these people in the beginning, but then a company came out and bought them.
Google.
Yes.
Yeah.
Google.
Why did you say words?
No, that was a joke.
They're not buying that.
Well, Google have all our information, don't they?
Why do you work for them?
No. Finding big dogs.
So this is an image of another set of
teams of quadrotors to autonomously build cubic
of quadcopters. They're very fancy quadcopters. So if you're doing anything with robots, you better do it with quadcopters so that they will be on all over the web, right? But the big question, the big problem these people were facing is: we have a design, we give you a number of items, then you sort out what is the best sequencing to actually install the structure. So these robots are not following precise instructions. They have generic, high-level aims. This is the target design. These are the items. You sort it out. So 5, 4, 7 robots, I don't know how many, negotiated between themselves the activities that each and one of them would activate to install an item. And so, I mean, they are cumbersome, of course, but you know that printers in the 60s were just as cumbersome, right? 60s, in the 80s. First printer I ever brought was a so-called Margherita. So it was like an old typewriter, except it was automated. And I'm not that old. I am old, but I'm not. I'm not dying yet. So we have made a lot of progress, and more progress is coming soon. Trust me on that, because, well, all of these videos, you should watch all of them, just because they are amazing. So
This video presents autonomous control capabilities for a quadrant helicopter. We use a 20-camera Vicon system and an onboard IMU for state estimation. Here we show single, double, and triple flips. We developed a method for flying to any position in space with any reasonable velocity or pitching. We use the method to fly through windows at various angles. Here there's less than 3 inches of clearance on all sides of the quadrotor.
automation in construction is coming.
Fly between other quadrants.
When it's coming is the next question.
The same method can be used to descend or ascend through a horizontal slot.
Anyway, I wouldn't like to have anything like that following me with a gun.
Drones.
But more realistically, contour crafting is here. No. Skip that. So you spit out a bit of concrete, you wait for it to consolidate, you go over it again, and you have built a house. Are they doing it big scale? Yes, they are doing it on large scale. I'll point you to the links. But the video, this is the nicest video that I've found, so there you go. Of course you have issues, because buildings will have also walls and things will have all sorts of integration of systems in them, right? You need pipeworks, you need electronics, you need all sorts of ducts, you need structural elements, but these are all things that can be taken care of. What else? So this is a printer. It's a 3D printer developed at Bath University. With this, they printed this. They didn't print all of it. They printed the initial plastic bits that allow people to assemble this. So you still have to buy the steel rods, you have to buy the electronic equipment separately. But the long-term aim of the RepRap project is to design a printer that is capable of printing all the items for another printer like itself. If you ask a biologist what life is, they will tell you that it is the ability to self-reproduce. Then they saw this and they said, oh, maybe it's not. So current research is really challenging the boundaries of our understanding of the whole universe. This has made biologists think and rework on their definition of life. But we'll keep this for the Q&A session later tonight. We'll also be presenting the coursework specifications for you for this course. So I'll see you later at 6 o'clock.